Okay, so up to this point, we have talked about basics of objects, how to create them, um, the the class attributes and variables, which is I should actually move the label down to here, not into the middle of that, but right there. Okay, we talked about access modifiers that limit the access or provide access to certain types of programs in certain other classes. We talked about the constructor, and we also talked about overloading the constructors. So this was the constructor. I should actually just label this. This is overloaded constructors. Okay, now in this video, we're going to be talking about the static keyword. So a lot of times students will ask, they'll say like, well, why is this main program static, but nothing else here is static? And as you recall, when we used to write methods, right? So if I wrote another method up here, it would be public static, I don't know, void some method, blah, 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 like that. All right, and this would have to be static. If you did not declare this to be static, then it would be very difficult to use this. Well, you'd get an error in using it. So what is the static keyword? What does that do? Well, what the static keyword tells the computer to do is to assign a memory unit to that item when the program executes. All right, so let's take a look at a program. If I create, say, int x is equal to 0 like this, that x doesn't exist when the program executes. It only exists when we actually create it in the code. Right? So same thing with our student here. So we have student, some student is equal to new student, and I'm just gonna, well, we can make it like this if we want, but we could never, for instance, just say student dot get first name. All right, and the reason why we can't do that, even though get first name is a method in student, okay, it's right over here, get first name. The reason why we can't do that is because there's no student that actually exists, right? We just have this concept of a student, an idea of what a student is, but we never actually told the computer to make a student variable or a student object, and so there's no instance of student to call it from, right? That's why down here you have to say some student, right? The name of the object, get first name. You can't just call the object first name. Right? Well, what that allows us, what we can do though, is we can declare certain things to be static. Okay, so let's say for instance, I made another variable here. So private, so another class variable. And I did something like this, private integer ID number. Okay, so you have a student ID number. And what I'm also going to do is I'm going to create something private and another integer, and I'm going to make that one the count. Okay, so what the count is going to be is a running count of how many students there are. Okay, so what I'm going to do though is I'm going to say private static int count. Now, what this means is that when we first run the program, this variable will be given memory in the RAM to exist. Okay, so it exists even before we create any students. Right, so I can demonstrate this by commenting everything here. Okay, and I can just say something like this, sysout student dot, okay, and it was count. Actually, I'd have to say get count, but that's going to give me a problem because it is private. So we'll have to go and create the getters and setters for them. But as you recall, creating getters and setters is not that hard in Eclipse because we can just go source, generate getters and setters, and select all, generate, and there we go. All right, so if we run this, you notice we can access that count even though the object doesn't exist. Right? We never created any students. So how is it that we can get the count? Well, the reason why we can get the count is because it is static, meaning it is given memory, so it does exist even before any other object exists. All right, so what we can do then is, let's say we go to our constructor and we can say count plus plus. So whenever we create objects, we can increase the count so they all know how many other objects there are, right? So keep count of how many objects there are. Okay, let's take a look. So I'm going to say student count, and the student get count is 0. Then I'm going to go and create a student object. Okay, so let's just say student S1. Okay, that's is equal to new student. Okay, and then I'm going to get the count again. Okay, so there's constructor 1, and now the count is 1. All right, well, what if I made another student, student S2? Okay, so S2 for student 2. Right, so we started off as our count was 0. We created student 1, and then the count went to 1. We created student 2, the count went to 2. But wait a second, what if I said sysout S1 dot get count? Okay, so I call it from S1, not from student. Right, well, student 1's count is still 2. Right, and that's kind of weird, right? But the reason why is because it's static. And when variables are static, it means that all objects defined of this type share this variable. All right, because it's assigned memory at the execution time, that all variables share this, all objects share this variable. Okay, so student 1 has this variable, student 2 has the same variable, so they share it amongst them. And an interesting thing you can do about this is you could say that the ID number is equal to the count, for instance. Now, they don't share their ID numbers, right? So we can increase the count by 1 and then set their ID number. And because they don't share their ID numbers will be independent from each other, but the counts will be the same. All right, so I can demonstrate this. Actually, I shouldn't have deleted that. Okay, so I can say s1.getID number. Okay, and I can say sysout. Okay, s1.getCount. Okay. All right, and then I can just repeat this action here for. Okay, I'm going to get rid of these other print lines here just because I think that it's going to be confusing for the output if I have that there. So I just create student 1, student 2, and now I have student 1 get ID number, student 1.get count, student 2 get ID number, student 2 get count. Okay, and you should notice that they will have the same counts, but they have different ID numbers. Okay, so student 1 has an ID number of 1, student 2 has an ID, or student 1 has a count of 2. Right? Why is that? Well, because both students were created, so they both share this count variable, right? But because their ID number was set according to the count, their ID number is not shared, and so therefore they're different. All right, so it's a way of making a shared variable. I can show you another example of how this is used. For instance, I can say sysout math.math. And if you notice, I could say math.py. Well, because math is a capital letter variable, okay, so 3.14159, okay, because this is a capital letter, we know this is an object. But if you notice, I never said math m is equal to new math. Right? I never had to make a math object, so there's no instantiation. And the reason why we can do this is because the pi variable is set to be static, right? So you don't have to actually create a math object. Okay, similarly, you can say sysout something like this, math.random. Right? Well, how is it that I'm able to execute this random number method without actually having created a math object to begin with? Right? Well, the reason why is because the .random method is actually declared to be static as well, which means that you don't actually have to create an object for it because it is already assigned memory. Right? So these things already exist in memory. So for instance, I could go over here and I could make another method, something like public static void, and I would have to make it public static void. Get count was set to be static because the variable was set to be static, right? So I could say public static void, say hello. All right, and just do a sysout hello world. All right, like that. And now this hello world method would exist even without any students existing at all. Okay, so for instance, I could just say student dot say hello. All right, and I can run that. I can run this method because without having an object created because it's static. Anyways, that's what static means. Now let's just go back. One last thing is, why does the main program have to be static? Well, if the main program wasn't static, it would mean that you would have to have a program object. In this case, the class is called program. So it would mean I'd have to instantiate a program object for it to exist and then run the main program. So I'd have to do something like this, like program P is equal to new program, so something like this. And then I'd have to say something like this, like p.main, like that, in order to run this main program. Okay, but if this was the case, well, where would I create this program object? Right, I would have to have another code to do that in. Right, well, how would I run that code? Right, well, I'd have to have an object to run that out of, and that's why the main program is static, because it would create an infinite loop of necessity in order to create programs to run other programs. So the main program is set to be static because it has to be able to be run without creating an object of this class. Anyways, that's it for the basics of objects. So we've covered the object attributes and variables, getters and setters. We've covered constructors, and now we covered the static keyword. So hopefully this helps. If you do have questions, throw them in the comments and I will be happy to respond. Remember to like and subscribe. Thanks for watching and have a great day.